Cool. Hello guys, hope you all had a good night. Let's roll with some automotive fun. So before I get started, I have a couple of questions for the audience. In 2023, how many companies do you think actually rolled out new features, not bug fixes, but new features through software updates in the automotive space? Talking about automotive car makers. 3. Actually, let's go with percentage. It's much easier. Right. 1%? Anyone else? 50%. So it's hard to believe. So 50% of the car makers last year actually rolled out new features into the cars over the air. Next question. Let's see if you guys can get this one right. So, I mean, there was a survey and all that stuff. So that's 44% of respondents said, okay, how much money are they willing to spend monthly to get new features and new services? A, 20. Again, think about last question, right? And then see how insane that was. 50. So this is what people told that they will actually be ready, to even pay to get new automotive services or vehicle services, right? So the whole we talk about software-defined vehicle, we talk about new features getting rolled in, we talk about the user experience in the car is actually happening. I mean, up until now, I mean, literally, I've done a lot of talks where I have a lot of slideware around this, but there was no data. There was no, okay, is this really happening? Are we talking about all this for real, right? Or is it all made up? So that's, these data points that some of the analysts actually followed up helps a lot because this is what is happening. And 2023 was a big year. 2023 was the year where software-defined vehicle to a large extent sort of started becoming a reality, right? So now, but still, right? Okay, where did Lewis Hamilton go? His picture was there. So anyway, but it's important for each one of us on how we drive our car. I mean, what does the driving really feel like, right? It's important for us to make sure that, okay, when we have, when we drive for fun or whatever, we need to have a car that actually sort of, just meets basic standards when it comes to driving, right? So at a high level, the automotive industry is going through some unprecedented change, and we've talked about it many times. Many people have actually written a lot of pieces about it. But again, the 3 fundamental trends that we see are more autonomy, okay, more features, more ADAS features and stuff, advanced user experiences. This could be, you talking to the car and getting some stuff done. For example, what's my tire pressure, for example, right? Electrification or alternative fuel propulsions, right? So those are the major trends. Now, what does it actually mean? It actually means you have much more increased complex software in play, okay? And then you have increased demand for high performance compute, AI related compute in the car, right? That's what it actually means. Now, given our traditional supply chains in the automotive industry and with these changes going on, how easy or how difficult it is for any automakers to switch to a software-defined vehicle, to enable all of these trends. And then, so it's just not, if you stick to the traditional OEMs talking to tier ones talking to silicon partners talking to technology partners and software ecosystem, it's not going to scale, right? Hence, we are seeing this major shift in the supply chain where everybody is talking to everybody, right? Which is what it should be. It's a massive disruption, right? Massive confusion. We've actually seen OEMs basically having their own software teams, announcing that they're going to hire 2,500 software engineers or 5,000 software engineers, right? But end of the day, what I'm trying to get to here is there is massive change happening. The supply chain is getting disrupted. There is a lot of sense that the OEMs are actually driving that, okay, we will have to focus on software. We will have to focus on enabling all of these 3 trends through new capabilities, right? Now, in specifically, again, it's important for a software-defined vehicle to enable new user experiences. It's important for it to enable new advanced driver assistant features, okay? And it is important for it basically to have new revenue streams. Again, fundamentally, the number of cars that get rolled out every year is not going to change drastically, is not going to basically, is not exponentially grow. It's about 85 to 90 million cars worldwide, okay? Combined, all the OEMs combined, right? Now, it's very essential for the OEMs to figure out new revenue streams. And that's basically what I was talking about earlier. So new revenue streams even after the car rolls out of the showroom, right? So that's why software-defined vehicle is important. Now, for us at Arm, we look at it as a full stack solution. It's not just the hardware, it's the full stack solution, and I'll explain why, right? So let's start with, when I say full stack, it's scalable automotive compute at the low level, it's virtual prototyping solutions that we are actually talking about and enabling these days with our partners, and then foundational automotive software, right? Can be non-differentiating software and also differentiating software, and then, of course, the applications that the OEMs develop across all of those three pillars that I mentioned earlier, right? So let's start with the lowest level, right? As most of you are aware, Arm, from an automotive product portfolio perspective, we hit every aspect of the automotive compute, starting from power efficient automotive MCUs all the way to autonomous vehicles. We have our IP technologies powering pretty much most of the OEMs across the spectrum, right? And last month, actually in March, we refreshed our product portfolio with the latest and greatest automotive CPUs and GPUs and ISPs and stuff. But one big change that we did in order to go and make sure that we meet hit the requirement of one of the pillars that I mentioned earlier is we launched the Neoverse CPU, right? We launched the Neoverse, which is the data center class CPU in Arm, into automotive by enabling safety features in it, right? Now, why did we do that, right? So there's a lot of demand for HPC compute in the car, a lot of demand for complex software to be written. So that was the fundamental reason we said, okay, let's go. This is where the trend is. Here is what we actually have to do. So we up-leveled our capability from a performance perspective from Cortex-A's to Neoverse, right? So that was a big change. Now, not just that, what we also announced was something called as automotive compute subsystems, right? Now, there's, our partners have a very wide range of automotive SoCs that they enable based on our IPs, right? At the same time, there is always this thing about, okay, can we, when we have our discussions, and I was talking about the supply chain disruption, when we have our discussions directly with OEMs and stuff, one of the key feedback that we've heard is, okay, can you, these IPs are fine, this is all great, but can you actually do more? Can you put together some of these things so we can actually then scale from there, right? So automotive compute subsystems, and I have a block diagram in the next slide, and what exactly it means is essentially Arm putting together CPUs and essential foundational building blocks for a chip from internally. We actually put that ourselves and then offer that to our partners, right? So what does it do? It standardizes compute platform at the low level, okay? That's number one. It enables software ecosystem primarily because once you standardize some of the low level aspects of the SoC, then it is much more easy to write debug codes. It's much more easy to write much more portable. Your debug codes can be actually portable, your security software can be portable, and so on and so forth, right? Now, a couple of other key important things is faster time to market. Now, generally, it takes, and these days, as the compute requirements and the SoCs are getting way more complex, just putting together the CPU subsystem is actually getting even more difficult, right? Quad cores, 8 cores, yeah, fine. But when you're talking about 32 cores, 64 cores, 128 cores putting together, it's not easy, right? So what we are doing is we are taking most of the burden in-house and trying to enable compute subsystems that already comes with the CPUs put together, right? So that enables faster time to market. And of course, lower total cost of ownership because we are taking in most of that and trying to eliminate the risks in the supply chain so OEMs can actually rely on us directly, right? So that is what automotive compute subsystem is, and this is an example picture, right? As I was talking about, on the left side, the blue box is what the automotive compute subsystem is. We launched this last year. This is under development right now. And as the previous slide said, we will have our first compute subsystems rolled out next year, okay? And if you look at it, and the cool thing about this is, there is a lot of flexibility that we are leaving to the OEMs and even the SoC partners around this. For example, we're not touching any of the AI accelerator piece, because we know that AI accelerator is an important differentiation for a lot of our partners. So we are just sticking to the CPU portion and standardizing that area, right? And then there is, of course, one of the key elements that we added is the safety island, because we know when it comes to enabling high mixed criticality workloads in automotive, you actually have to have an ASIL Delta engine that can actually run super high safety safety capable workloads. And at the same time, you also have some of the other workloads which doesn't need so much level safety. So we have that mixture enabled in this automotive compute subsystem, right? So then moving up the stack, from the scalable hardware, starting from MCUs all the way to automotive compute subsystems, we talk about virtual prototypes. Now, fundamentally, what we're trying to do here is when ARM supplies IPs to our partners, it generally takes about 12 to 15 months for them to put together the SoC after we release our IP, and then enable a virtual platform to their partners. Okay, I'm talking about silicon partners here, right? And then enable that to the software ecosystem for software development. It's roughly about 15 or 18 months of after we launch our IPs is when there can be a platform available for software development. That is what we wanted to change, because in this world where we are talking about enabling software as early as possible, at the same time, not knowing what the workload will be 3 years down the lane when the IP will eventually go to the car, or 5 years down the lane, it's important for us to ensure that we provide a platform where software development can actually happen simultaneously alongside the SoC development. That is the most important part of the investment that we are doing in virtual platforms, okay? And what are we doing, right? So let me give you an example. Back in 2021, so our automotive product roadmap refreshes once in 3 years. The last launch was in early 2021, and the most recent one was in 2024. The first platform that was available for software development based on our 2021 IPs was in second half of 2022. Right? It's about 18 months roughly. Now, in March 2024, when we did our IP launch, we were able to enable virtual platforms based on our current generation latest IPs on day one, working with our EDA partners. So there was virtual platforms on our IP available by the EDA partners on day one, right? So what did that do? That enabled so these are the partners that we worked with. We worked with Siemens, we worked with Corellium, we worked with Cadence, and then we enabled that virtual platforms on day one. Now, what did that do, right? That enabled all of these software partners who were able to enable their software and middleware on top of our virtual platforms at the same time, right? So that was the change. I mean, literally, we were able to pull in about 18 months of just platform availability for software development, right? And that is now continuing with a lot of our partners enabling their software and doing software development for the OEMs simultaneously as the SoC development is actually happening, right? So that's fundamentally about 12 months from now or 18 months from now, the OEMs will pick the right SoC that they want from our partners, but they would have had the software development already running in parallel. That is what was important from the virtual platform initiative, right? We will continue to invest in that. And another key aspect here is this was possible because of the initiative called SOFI. I'm not going to talk SOFI too much here, but at least in this slide. So we enabled SOFI back in second half of 2021, where we were fundamentally trying to standardize some low-level non-differentiating software in the ecosystem, right? Because we did that back then, there was this community that was formed who were then able to move their software from the previous generation ARM-based SoCs to new generation using our framework, right? And this is the entire list of partners who partnered with us for the launch, right? And it was, again, a complete change in the way ARM does IP launch, and this is very, very significant for us because it kept software in the forefront. Right, can I get some water? All right, so moving on. So yeah, so SOFI was launched in September 21. And fast forward now, there's been a significant, sorry, just. Thanks. All right, so SOFI was launched back in September 2021. Since then, we've had very, very good traction in terms of what we are standardizing, right? And we are now here where we are specifically sitting on a good ecosystem, participating and collaborating across multiple different aspects of automotive software. Now, where are we taking it, right? So, three key aspects. One is we have the virtual platforms that I just talked about. We're scaling that, on the left side, we're scaling that to compute subsystems. We are enabling the primary compute that I talked about, multiple CPUs, and the safety island. We're enabling that virtual platform together. We are then working with the virtual platforms. We're working with our ecosystem, trying to enable the virtual platforms. And then we actually are scaling it up from working with Linaro together to enable a complete CI/CD framework and testing. All right. So, let me just go through this one at a time, right? So first of all, the Evol 2.0. So this is, again, up until now, we have seen on the right side, which is enabling something called as Meta Evol, which is fundamentally, standardizing the three layers of software that you see there based on ARM standard firmware. Now, next, where we're taking this is enabling on the left side, which brings in the safety aspects of this and merges that into a much bigger framework, right? So that mixed criticality workloads that I was talking to you about can be enabled right at the foundation level, so that applications and blueprints can be enabled on top of it from that point, right? Now, the next is, again, talking about virtual platforms, now enabling all of that infrastructure both in the cloud using virtual models from our EDA partners and making that available to the physical silicon as well, right? So the first step that we are doing is enabling all of that infrastructure from a software perspective, passing that on to our EDA partners who are enabling virtual platforms and enabling that on top of the virtual platforms, and then taking it on to complete software development and enabling a complete ISA parity from cloud to virtual platforms to the end car. Because right now we have Neoverse-based CPUs in the cloud, and that is driving this ISA parity all the way from the cloud to ARM-based CPUs on the car, right? So that ISA parity is what we're driving through these initiatives, first by enabling the foundational software and then moving that into the software, into the virtual platform environment. Now, we are then partnering with Linaro, right, primarily to enable this integration of Evol 2.0, right, that is bringing together the safety and non-safety components of the Meta Evol, enabling that on virtual platforms and enabling the testing infrastructure on the virtual platform, and then taking that into functional testing when the real platforms are available. So we already have our integration lab that we are working with Linaro, right, for SOFI, and that integration lab is now going to get scaled primarily to enable all of these three aspects in the future as well. So going into the compute subsystem, we have the foundational software, we're enabling virtual prototypes of that compute subsystem, and then enabling this infrastructure for a complete CI/CD services and testing in partnership with Linaro. That is where this is going next, and fundamentally, looks like, we are utilizing all of the investments and work done by the entire community for the last 3.5 to 4 years based on SOFI and all the other work that we did, and then taking that forward to the next stage where we have this compute subsystem play and virtual platform play, and then merging the whole virtual platform validation and the real platform validation in partnership with Linaro. So that's where we are going with this, okay? So back on this, again, finally, we're talking about full stack, right? It is very, very important for each one of us. Look, for us as a technology provider, the reason why we see this as a full stack problem is it's, end of the day, when we build our IPs, when we build our compute subsystems, it's important for us to ensure that we understand what the applications are. We understand, what software is going to run on top of it. How is that going to basically drive the requirements into it? What is what is changing? How is that basically sort of influencing our system IP requirements, our bandwidth requirements, our performance requirements, and so on and so forth. So that's the major reason why we think about a full stack, when we think about it as a full stack, from a full stack perspective, right? Now, with that, I mean, again, as I said earlier, we're facing a much bigger challenge in the industry, a lot of disruption, a lot of new challenges, a lot of new requirements from the customers. And then, we are driving this as a full, from an OEM perspective, they need a full stack solution approach. They need every component supplier to think about it from a solution standpoint. And this actually needs a widespread collaboration. No one company can actually do this alone. And hence, specifically, as I said, it's, we are utilizing all the environment ecosystem work that we did so far, at the same time offering our new technologies back into the ecosystem so that we can scale this across, the entire automotive market. So with that, thank you.